PreCalc 10.3 Geometric Sequences and Series. So we did arithmetic sequences before, and we used our first and last terms. We used n, which was our number of terms. We found our sums, and we used that d, which was the difference, the common difference. So today with geometric sequence, we have sequences in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. So where we had the constant, the difference constant with arithmetic, we're going to have the common ratio with the geometric. And again, we get this one by multiplying. Now, we're going to stick with the idea of always multiplying. Technically, sometimes it looks like we're dividing, but when we divide, we're just going to multiply by a fraction to get that same division. So we're going to start out just like we did last time with our arithmetic sequence, but this is with our geometric sequence, and we're just going to write the first so many terms of each sequence. So on my first one, for number 1, I have my first term, which is A1 equals 24, and we're going to use the ratio, the common ratio here of 1/3. Okay, so to find A sub 2, I'm just going to take A sub 1, the last term in the sequence, times the common ratio of 1/3, and I get 8. So for A sub 3, I'm going to take the last answer I got of 8 times my ratio of 1/3, and I'm just going to leave it as a fraction 8/3. For my fourth term, I'm going to take my last answer times my common ratio, which is 1/3, and I get 8/9. And I need one more term for the fifth that did say for the first 5 terms. I'm going to take 8/9 times my 1/3, and I get 8/27. And I could keep going on, but these are found by multiplying by the common ratio instead of the adding or subtracting we did with the common difference. All right, let's try our next one. You'll notice that this one is written in the recursive formula like we've had before. So here's my recursive formula. A sub n equals -6, A sub n minus 1. And we need our common ratio. So remember the A sub n minus 1 is part of that recursive formula, always going back to the term before it. But in this case right here, we look and that is being multiplied by a -6. So that is my common ratio, is my -6. So I start with A sub 1, which is -2. So to find A sub 2, I'm going to take my -2, and I'm going to multiply it by my ratio of -6, and I get +12. So for A sub 3, I'm going to take my +12 times my -6, and I get -72. For A sub 4, I'm going to take that -72 times a -6. I might need a calculator now. I do get a positive number, I do know that. How about a +432? And for my fifth term, I would take my +432 times my -6, and I get another negative term, which is -2,592. I do want to point out on this one, this pattern of a positive number, a negative, a positive, a negative, goes on and on and on. So if you ever see that, remember that you need that negative on your ratio because, of course, a negative times a positive is negative, but a negative times a negative will get you that positive back. All right, so you're going to see a lot of what we see in the notes today are similar to those arithmetic as far as writing a general terms equation, things like that. When we turn to the next page, we'll be doing some summations and such. So here we have the general term of the geometric sequence. Again, similar to what we saw on the arithmetic. This one says A sub n equals my first value times r to the n minus 1 power. Okay, again, because we're multiplying this one, we have r to the n minus 1 power instead of where we saw that n minus 1 times my d the last time. So we're going to use this formula for the general term of the geometric sequence to find A sub 40 when A sub 1 equals 1,000 and my r is -1/2. So I'm going to just go ahead and plug right into this formula. A sub 40, remember this is kind of notation on the left, equals my A sub 1, which is 1,000, times my ratio of -1/2 to the 40 minus 1 power. Okay, a lot of order of operations going on here that we need to be careful with. I'm going to rewrite my 1,000, and I'm going to make sure I simplify, so I'm going to have -1/2 to the 39th power. Remember, dear Aunt Sally tells us to do parentheses. Well, my parentheses are really just holding in that negative 1/2. But then the next rule is exponents. So we need to take care of that exponents before we do any multiplication. So if you go to your calculator and plug in and put this in a parenthesis, because otherwise it'll lose that negative and you'll be in trouble. Negative 1/2, and you're going to take it to the 39th power. Remember that little caret key can be your to the, right? And then I can type 39th power. And when I do that, I get this huge scientific notation decimal, okay? So I have 1,000, and I get this value of, I'm going to round because I need to, negative 1.8 times 10 to the negative 12th power. Okay, now the advantage I have right now is that number's still stuck in my calculator. So if I take it times my 1,000, I get a more accurate answer, right? I get negative, a sub 40 is going to be negative 2. I need to put this in scientific notation because I have all kinds of zeros. So it looks like it's about, if I round, it's like negative 1.8 or negative 2 times 10 to the negative 9th power, okay? So it depends whether you put it in scientific first or if you take the decimal. If you left the decimal from your calculator, it's like 0.000, you get all those 9 places until you get to the 2. So I'll take this, or if you use your calculator, negative 1.8 times 10 to the negative 9th. Either one of them is acceptable. Okay. And just a heads up, when you have these ratios that are fractions, when you go to higher and higher terms, of course your number's going to get smaller and smaller. So you're going to see the scientific notation pop up if you get into really high terms. Okay, so don't be shocked when you see that. All right, example 4 here. We are writing a formula now. We're going to use this to write the general term of the sequence, then use it to find a sub 7. Okay, so first we're going to just write this the generic. So we're going to start out with a sub n equals a sub 1 times r to the n minus 1. So if I don't know what I'm finding, I leave this a sub n. My first term obviously is 5, and I need to find my rate. Well, what's happening to go from 5 to negative 1 to positive 1/5 to negative 125? I can definitely tell when I look at this, because I'm going positive, negative, that my r involves a negative. 5 was large, went down to 1, went down to 1/5, went down to 125. Looks like I'm dividing by 5 each time. But remember, we don't do division, we just do a multiplying. So how about times the fraction 1/5? Okay, that's going to be my r. So I'm going to do negative 1/5. And again, this is the generic equation, so I'm just going to do n minus 1. And I'm going to tell you right now, there's nothing I can do to simplify that. I cannot join that 5 and negative 1/5 because the negative 1/5 has a power on it, so we can't join those two together. That is the equation. I don't do anything else with it. Now I'm going to use it to find my 7th term, so I can plug in 7 for everything where I see n. Remember, on the left, that's just notation. Over on the right, it now becomes my power. So I get 5 and the negative 1/5 to the 6th power. Again, order of operations, make sure we take that negative 1/5. Make sure you use parentheses around that negative 1/5, especially with the negative in there, to the 6th power. I do get that tiny decimal again, times my 5 out front. And it still gives me a scientific notation. In fact, I left my calculator in scientific notation. 3.2 times 10 to the negative 4th is what I'm going to leave this one in. Okay. And if you can, just if you have a calculator similar to what we use in class, up by the dirge button, remember the degree, radian, and gradient button. Above that, it says scientific and engineering. If you do the second on that, you can choose scientific notation on your calculator. And if you don't, you can just count all the zeros. That's always an option. All right, page 2. We are going to find the sum of the first so many terms of a geometric sequence. So these are our finite sequences that actually end, and we're going to try to find the sum of all of those. All right, these are definitely different than the arithmetic as far as I don't have a great example to show for you. All I can say is trust the formula. So we have this formula, the sum of so many numbers, that's what our n stands for, is the first term times 1 minus r to the nth power all over 1 minus r. Okay, obviously on here, my ratio cannot equal 1 because if it did, then I'd go away and any would see a geometric sequence because nothing would ever change. All right, so let's look at this. To find the sum, we need to know the first term, we need to know the common ratio, we need to know the number of terms. So that's the things we need to make sure we can find, and once we know those, we can find the sum. So how many terms do we have here? Find the sum of the first 14 terms, so n is going to be 14. My a sub 1, my first term, looks like it is negative 3/2. And I also need to have my rate. So what is happening from negative 3/2 to 3 to negative 6 to 12? I'm definitely going negative, positive, so my rate has that negative on it. And it looks like I'm getting larger. 3 over 2, then I get 3, then I get 6, then I get 12. So it looks like I'm multiplying by just 2 each time. And then, of course, that negative 2 because it goes positive, negative, positive, negative. If I know those three things, I can use my formula. The sum of my first 14 terms will be my first term, which is negative 3/2, times 1 minus my rate, which is negative 2. Notice the minus, and I put my negative 2 in parentheses, and it's going to be to the 14th power all over 1 minus, again, watch that minus negative 2. Okay. Dear Aunt Sally wants us to follow our order again, so be real careful here. So I'm going to leave negative 3/2. I have 1 minus, and this is where I need to take negative 2 to the 14th power, okay? Again, watch that negative, make sure it's in your parentheses when you take it to the 14th power. I do get a positive number now, and it's about 16384 all over 1, and my minus and negative becomes plus 2, which is 3. Okay, so I get negative 3/2 times negative 16383 all over 3. I'm going to be honest, let's let the calculator do it all from here. And I'll get the sum of the 14th number is negative 3/2 times negative 16383 divided by 3, and it looks like I get about 8,191.5. And remember, when you're adding these, you're adding a positive, the next time you're adding a negative, the next time you're adding a positive, the next time you're adding a negative. So you definitely get that number swings back and forth as you add a larger negative and then a larger positive and then a larger negative, and it keeps going from there. So sometimes just to change it to the 15th term, you get a completely different sum because then it would get one more negative on that list. So it definitely depends where you're at on that list when you're going with those negative ratios. All right, let's try another one. This one is written in summation format, but remember we still want the same things. We need an n, and if you can read that top number, which I seem to have covered up, that's a 7 up there. So it looks like I'm going to have 7 terms total. My a sub 1 I need to find, and my r, if we think about it here, when I see this formula right here, 4 times negative 3 to the I power, I being my index. What is going to multiply over and over and over as my I increases? Well, it looks like negative 3. So my ratio is negative 3. And let's find our first term. So a sub 1 would mean I'm going to plug in 4 and negative 3 to the 1 power. Well, negative 3 to the 1 power is just negative 3 times 4 is negative 12. So my first term is negative 12. And we have the information. We're ready to find our summation. So summation of the first 7 numbers of the sequence will be negative 12 times 1 minus my rate, which is negative 3 to the 7th power, all over 1 minus negative 3. So a little simplification, negative 12 times 1 minus negative 3 to the 7th power is, I'm suddenly wishing I was not in scientific notation, negative 2,187 and that's all going to be over 4. All right, so it looks like it's 1. It's going to be 1 plus that 2,187. So it looks like I have negative 12 times 2,188. When I add that on, divided by 4, let the calculator do the work. And it looks like I get a sum, and this one is negative. Sum of my 7 numbers will be negative 6564. So again, if you have the formula handy, it's ready to go. Okay, one thing I want to show you, and again, I chose my examples carefully, but I have a rate of -2 and a rate, I should say ratio, not a rate, common ratio of -2 and a common ratio of -3. The negative obviously affects the signs, but my numbers 2 and 3 are larger than 1. If you happen to have a ratio that is smaller than 1, and that's just the absolute value of the ratio that's smaller than 1, then you're getting closer and closer to 0, because what you're doing is you're always decreasing your number and you're getting it smaller and smaller. So it kind of gets to the point where you get to where you're adding less and less and less each time. And we can call this an infinite geometric series because you're getting closer and closer to 0. So this one, if you have a ratio, the common ratio is smaller, they kind of, if you can read in the box here as I'm trying to move it, if your ratio is between -1 and 1, so whether it has a negative or not, it doesn't really matter, but if your ratio is a small fraction, you're going to get closer and closer to 0 each number that you add on. And so we simplify this formula a lot. And by the way, this is an infinite, so it means I keep adding numbers. It doesn't matter how many terms there are. So we lose the n in this, and the summation is just the first term divided by 1 minus r. Okay? So it's similar to the top, it's kind of simpler, but we can only use this when our ratio is small. Okay, so it says find the sum of the infinite geometric series, and you'll notice I have a 1, a -1/2, a positive 1/4, a negative 1/8, positive, it'd be like 1/16, and goes on and on. So I need to know 2 things this time. I need to know my first term, which happens to be 1, and I need to know my common ratio, which it looks like I'm taking half each time, and it also looks like I'm switching signs every other time, so it must be a -1/2. Okay, so to find the sum of this infinite geometric series, I just start with my first term on top and 1 minus my -1/2 on the bottom. So that becomes 3/2. And if you think of our fraction rules, that's the top divided by the bottom, or the same thing as 1 times the reciprocal. So it looks like if I would add all the terms in this sequence, they're going to add up to a whopping 2/3. All right. We have one more here, and this is kind of an interesting way to think about how you can rewrite a repeating decimal as a fraction. Okay, it's one of those things we learn once upon a time, we forget what we're doing, but anyways, here we go. So I have this decimal of 0.47 repeating. So if you think about it, it's like 0.47474747, and it keeps going on and on and on. If I take this 4/7, the first 2, if you think about it, that is 4/7 in the hundredths place. So that's this fraction 4/7 over 100. Then the second one of set of 4/7 would be over the 10,000ths place. Okay, so that's where we get 47 over 10,000. My next 4/7, if you think of the place values, well, that's over the millionth place. Okay, and we could keep going. So this decimal can be written as fractions being added on each time as you keep going out to more and more places, okay? So once again, this is a summation, and because I need to find my ratio here, my first term is 47 over 100, and the common ratio, if you think about it, my 47 stays the same on top, so nothing's happening on top. And on the bottom, we're adding 2 more zeros every time. So that's kind of like just multiplying by 100, adding 2 more zeros every time. We don't have a sign change, so it's just positive 1 over 100. Okay, that's what we need to know. We can use the same summation formula that we used just above in example 7. So my summation is going to be my first term on top, 47 over 100, over 1 minus my rate, which is 1, or my ratio, I should stop calling it a rate, 1 over 100. Okay, so we get 47 over 100 on top. 1 minus 1 over 100. Well, think of this 1 as 100 over 100. Minus 1 over 100 leaves me 99 over 100. So that's the top fraction divided by the bottom fraction. Or another way of putting that is keep, change, flip. And my 100s cancel, and I am left with the fraction 47 over 99. And that will be the summation, or another way to write my repeating decimal is 47 over 99. And that's it. That's geometric sequences. All right? So if you would like to practice, get that textbook out, right? And some good problems to try are page 983. And we're looking at 3 through 54 by 3s. And remember the big difference between arithmetic sequences and geometric sequences is arithmetic have difference, and geometric ratios have, or sequences have the common ratio. So have fun, practice. Let me know if you have any questions.